Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of P3 variant 33 of June 2020. And for this, I am using the work of an outstanding and one of my best students, Miss Hadia Sayyed of class 2021, the Lyceum. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles and degrees, unless a different level of accuracy is specified in the question. Must follow all these instructions. An important advice for me and for everyone, we should be positive. 2 important tips to solve the paper in a good way. Number 1, read questions carefully. Number 2, avoid careless mistakes. Question number 1. Solve the inequality. By squaring on both sides, we can remove these two modulus. Make sure you must square this 3 as well. When you will square this 3, it will become 9. Now, by expanding both of these expansions, we have this inequality. By bringing everything on left hand side of this inequality and by taking common 5 and by breaking the middle term, we have this completely factorized form of this inequality. Since we have lesser sign, so this is the required region, hence the solution of this inequality is x lies between -7 and -1. Question number 2. This question is of integration by parts because we have product of different functions. So if this is u, this is simple. You could use by parts straight away. You can suppose this as u and this as dv. But this student expanded the bracket and she applied by parts here and she integrated this directly. Both the methods are fine. This method is simple. If you will assume this as u and this as dv, then you can easily handle this. Well, according to this method, we have to use by parts here. So this is u and this e minus 2x with dx is dv. You all know we always differentiate u to get du and we always integrate dv to get v. This is the by parts formula. So this is u and this is dv, this is v, and limits are 0 and 1. This is v and this is du. We just need to apply limits here and we have to integrate this. When we will integrate this, we'll get e power minus 2x upon 4. And this is the simplified form after applying the limits. See, the integration of this is very simple. This will become e power minus 2x upon minus 2. And this 2 is as it is. This solution is here. Now, by applying limits on this part, we have this. And this is the simplified form of this integral. You must be good at algebra. You have to give the exact answer. If you want to take the screenshot of this solution, you can. Next question. Question number 3. This is the logarithmic equation. First, we need to remove ln from this equation. You all know how to remove ln. This is the index form. Ln y is equal to x. This is the logarithmic form. When you will remove ln from this logarithmic form, you will get y is equal to e power x. The base of ln is always e. So when you remove ln, this y will be copied and this e will come here. Same is here. This ln has base e. So when you will remove this ln, this e will come here. I mean, this minus 2x will become the power of this e. Now you need to suppose e power x as u. So when e power x is u, then this will become u power minus 1, and this will become u power minus 2. By simplifying this equation, we have this equation. Since u is e power x, so we have e power x here and e power 2x here, minus 1 is here. We had to show this thing. We had to find an equation which is the quadratic equation in terms of e power x. This is the required quadratic equation. Hence solve this equation. That means you need to solve this equation. So by using quadratic formula onto this equation, we have this thing. So we have two results, one with plus sign and one with negative sign. You all know ln is invalid for negative values, so this answer will be rejected here. Since we are working for x, so we need to take ln on both sides. When we will take ln on both sides onto this equation, we'll get this equation. And this x will become the coefficient of this ln e, and ln e is 1. So we just have x here, and this is with ln. This is the final answer up to 3 significant figures. You must mention this, invalid. Question number 4. The equation of a curve is y is equal to x times tan inverse half x. This is uv. We need dy upon dx. So by using uv rule, which is uv prime vu prime, we can easily differentiate this. So this will become dy upon dx, and according to uv rule, we need to copy u and we need to differentiate tan inverse half x, and this is the way to differentiate tan inverse half x. See, tan inverse half x will become 1 upon square of this angle, x upon 2 whole square, plus 1 of the formula, and the differential of x upon 2 must be here. The differential of x upon 2 is 1 upon 2. So this is uv prime. Now do vu prime. This is v, and this is u prime. U is x, so u prime will be 1. Now you just need to simplify this, and this is the simplified form. You must know the differential of tan inverse. This is the differential of tan inverse half x. You need to learn this by heart. Part B. The tangent to the curve at the point where x2 meets the y-axis at the point with coordinate 0p. So first we need to find the equation of tangent at x2. And first we need to put 2 here to get the y-coordinate. The y-coordinate of this x2 is this pi by 2. And we need gradient of this tangent as well at x2. So by substituting 2 here into this equation, we can get the gradient. This is the gradient of the tangent. Now this is the equation of the tangent. Y minus y1, m x minus x1. And at this point, y is p. So you can write p here. This is the value of p. First get the equation of tangent and then substitute this y by p. This is the required value of p. Question number 5. By first expressing the equation as a quadratic equation in tan theta, solve this equation for this domain. This is simple, we just need to use sum of angle formula here. The sum of angle formula for tan is this: tan theta plus tan 45, 1 minus tan theta tan 45. And this cot 2 theta will become 1 upon tan 2 theta. And we know the formula of tan 2 theta. It's 2 tan theta upon 1 minus tan square theta. So since this is in denominator, so the formula is this. This is the formula of 1 upon tan 2 theta. Tan 45 is 1. So this is 1, this is also 1. Now we just need to do the cross multiplication. So this is 1 minus tan theta, 1 plus tan theta. We cancelled these two terms because tan theta is not minus 1. I mean, since we are working only in first quadrant, therefore we can cancel these two. If we don't have this domain, then we can never cancel these two. These are variables. We can never cancel variables in numerator unless we have some specific condition. This is the condition. Since we are working in first quadrant, so tan theta is not equal to minus 1. That is why I cancelled these two. Otherwise, you can, in general, you must not cancel these two. You need to factorize the equation carefully, otherwise. Now we have this equation. So by bringing tan square theta here and expanding this, we have this equation. This is the quadratic equation. Now we just need to solve this. So half tan theta and theta, this is the alpha. And since we are working in first quadrant, so this is the required value of alpha. Question number 6. By sketching a suitable pair of graphs, show that the equation has exactly one real root. This is so simple. You just need to sketch this separately and this separately. You can make the boxes for these two functions. Let y be x power 5 and then y be 2 plus x. So with the help of these values of x and y, we can easily sketch this line. This is here. And with the help of these values of x and y, we can easily sketch this curve. This is here. And according to this sketch, we have just one solution shown. The next part of this question. Show that if a sequence of values given by the iterative formula converge, then it converges to the root of the equation in part A. This means you need to convert this equation into this form. So it's given the formula converge. This means xn plus 1, xn, they all are equal to x. When the formula converge, then xn plus 1 and xn, they all are equal to x. So by substituting or by replacing all xn's and n plus 1 by x into this formula, we have this equation. Now we just need to bring this equation into this form. It's here. Make sure you understand this statement. Converge, the iterative formula converge. That means this thing. Next part. Use the iterative formula with initial value 1.5 to calculate the root correct to 3 decimal places. This is so simple. You just need to use calculator. You need to substitute this equation into calculator first, and then you need to put 1.5. And you have to mention the iterations up to 5 decimal places. And you have to repeat the process unless you get a repeated number. Hence the answer is 1.267. We have to give our answer up to 3 decimal places. Make sure you must follow these restrictions. Question number 7. This is f of x. Express f of x in partial fractions. This is so simple. Both the factors are linear. So, and we have two factors, so we have to split this fraction into two fractions. And since both the factors are linear, so we must have constants in numerator. So, by multiplying both sides with this denominator, we have this equation. See, from this factor we have x half, and from this factor we have the value of x, which is negative half. By substituting these two values one by one into this equation, we can get the values of a and b. Therefore, a is 1 and b is minus 1. Hence, this is the required partial fraction. Make sure you must substitute the values of a and b into this equation. Always suppose this as equation 1 and substitute the values of a and b into this equation. Part B. Using your answer to part A, show that. This is so simple. This is f of x. And we have f of x whole square. So we just need to square both sides. Squaring on both sides. So when we will square this thing, we will have this. And you know this is a minus b whole square. So by expanding this expansion with the help of a minus b whole square formula, we have this a square minus 2ab plus b square. Just need to simplify this. This is 2, and we just wrote this 2 as 1 plus 1 so that we could break the LCM. Finally, we have this 1 upon 2x minus 1, 1 upon 2x plus 1. Last part of this question, we have to integrate this thing with these two limits 1 and 2. See, the power is not 1, so you need to bring this expansion in numerator, this as well. Since the powers of the expansions are 1, so we need to use ln to integrate these expansions. One important thing, this is not 1 plus 1. This is 2 upon this thing. And since we have this fraction here, see, so by substituting this thing here, we have this. We basically substitute the value of this here, this thing here. So this is the correction. This is 2 upon this bracket and this bracket. And here we use this result. We substituted this by this thing. This thing is here. Well, I already have explained you that you need to bring this in numerator, this as well, because the powers of the expansions are not 1. Here the powers are 1, so we need to use ln here and here. This is simple integration. Add 1 in power and divide the function by the resultant power and the differential of the expansion. Same is here. Here you have to use ln. So the differential is 2, so it's here. 2 is here. Now you just need to apply, you just need to get the simplified form of this thing first, and then you need to apply the limits. When you will apply the limits and when you will do the algebra, you will get this thing. You need to do these calculations very carefully, and you must be good at algebra. You must be good at ln as well. If you want to take the screenshot of this solution, you can. This 2 came here, and then we use quotient law of ln. Question number 8. So we have 3 position vectors, OA, OB and OD. A fourth point C is such that ABCD is a parallelogram. This is so simple. Make a rough sketch. Always make a rough sketch. Find the position vector of C and verify that parallelogram is not a rhombus. For position vector C, we have 2 options. Number 1, we can use these 2 vectors. AD is equal to BC, or we could use these 2 vectors. AB is equal to BC. You have options. You can use any 2. Opposite vectors are equal in parallelogram. So AD is equal to BC. You all know how to write AD in position vector form. This will be OD minus OA, and this will be OC minus OB. You are working for OC. We have everything, OD, OA, OB, so this is OC. Well, for rhombus, all adjacent sides are same, all lengths are same. All lengths are same. This means rhombus. And the angles of diagonals intersect at right angle. So you have 2 ways to prove rhombus. Number 1, you can find the lengths of any 2 adjacent sides, and they must not be equal if this diagram is not a rhombus. Number 2, you could find find the dot product of these 2 diagonals, and the dot product must be 0 because diagonals intersect at right angle. So if dot product is 0, then the diagram is rhombus. If it's not, then the diagram is not rhombus. In this case, the dot product must not be 0 because we have to prove that parallelogram is not a rhombus. So you have both the ways to solve this question. The simplest way is this: get the length of any 2 adjacent sides. So BC vector is this, and AB vector is here. Now check the magnitudes. The magnitude of this vector is 3, whereas the magnitude of this vector is under root 14. Since these 2 lengths are not equal, therefore this diagram is not rhombus. This parallelogram is not a rhombus. It's here. The next part. Find angle BAD. We need this angle BAD. For that we must have these 2 vectors BA and AD, and then we will find scalar product. So AB AD, you write this in this way: AB dot AD. BAD means, read in this way: AB dot AD. This is the scalar product formula. Take the dot product of these 2 vectors carefully. The dot product is I guess -6, and their magnitudes are here. The angle is 100.3. Make sure you give your answer up to 1 decimal place. Now the last part, find the area of parallelogram. This is so simple. See, get the area of this triangle and then multiply this by 2 to get the area of parallelogram. So area of this triangle is half AB sine C. half AB sine C, and multiply your answer by 2 to get the area of parallelogram. This is the area of parallelogram. Next question. The complex numbers u and w are such that these are simultaneous equations. You just need to solve these two equations simultaneously. So you have option. You can either find u or w from this equation and substitute the value of that quantity into this equation. So by finding u from this equation, we have this. And by substituting u here, we have this equation. This is the quadratic equation. Now you need to use quadratic formula. By using quadratic formula onto this quadratic equation, we have two values of w, this and this. Therefore, we must have two values of u. So by substituting these two values of w one by one into this equation, we have two values of u. 1, 2. The next part of this question. On a sketch of an Argand diagram, shade the region whose points represent complex numbers satisfying the inequalities. You need to observe these inequalities carefully. When you will take minus sign common from these two terms, then this inequality will become the circle, equation of circle, of center 2 plus 2i and radius 2. This is argument from 0 to 45, argument from origin. This means real part. Real part means horizontal line. This means x less than equal to 3. So, circle with radius 2. This is here. And according to this inequality, you need to shade inside this circle. This is argument of z from origin, and the range is from 0 to pi by 4. This is 0 and this is pi by 4. Make sure this argument line must passes through the center, because the coordinates of center are 2 plus 2i. Plus 2i, and this is the real x less than equal to 3. This line is here, and make sure the line of argument must be half. It must not be extended over here. The line must start from origin. This is very important. Don't extend this line here, otherwise you will lose 1 mark. This is the half line. This line is known as the half line. Well, according to this inequality, you have to shade inside this circle. So these are 3 required regions, 1, 2, 3. According to this inequality, the argument z lies between 0 and 45. So this region must be shaded. And according to this inequality, x is less than equal to 3. So this region must be shaded. So this is the combined region, and this is the required region. Next question. Question number 10. A tank containing water is in the form of a hemisphere. The axis is vertical. The lowest point is A, and the radius is r. Therefore, height must also be r. This is the height. Well, the depth of water at time t is h. This is here. At time t0, the tank is full. Means at time t0, the height is r. This is at t0. At this instant, a tap at A is opened and water begins to flow out at a rate proportional to under root h. So this is dv upon dt. And flow out means decreasing, rate of change of rate of decrease of volume. The tank becomes empty at T14. That means at T14, height will be 0. So, dV upon dt is proportional to under root minus h. Therefore, dV upon dt will be minus k under root h. This is the volume when the depth is h. Volume of this sphere. Now we have to show this equation. We have to use chain rule. Why? Because the rate of volume is given and the rate of depth is required. When one rate is given and another rate is required, we always use chain rule. And for chain rule, we must have dV upon dh, and we can easily get dV upon dh by differentiating this equation with respect to h, which is here. Now by substituting these two values, the values of these two quantities into this chain rule formula, we have this thing. Now we have to make dh upon dt subject. This is here. And we have to write b here. Since we have b, so we have to suppose this constant minus k upon pi as b. This constant is known as arbitrary constant. So we just need to compare this result with this result. Everything is same except this thing. So we need to replace k upon pi by b. Hence shown. This solution is important, so if you want to take this screenshot, you can. Next part. Solve the differential equation and obtain an expression for t in terms of h and r. Number one, we have to go for the variable separable. We need to bring dt here and this entire thing here. Now we need to integrate this and this. R is constant, so just leave it. So h power 3 upon 2 divided by 3 upon 2, which will become 4 upon 3. This is here. This will become minus bt plus c. Now we have two things. At t0, h is r, which is here. And at t14, h is 0. With the help of these two conditions, we can get the values of b and c. C is this and b is this. By substituting c and b here and here, you can easily get this thing. A lot of algebra is involved. You must be good at algebra. You can take the screenshot of this solution if you want. Well, this is all. An important advice for me and for everyone. Always dress well. Good luck. And I am extremely thankful to Miss Hadia Sayyed who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. May Allah Pak give her the best grades. Ameen. Allah Hafiz.